All right, so we are good with the homework then? All right. So, folks, if you want to turn in the Chapter 3 homework because you have it done, you are more than welcome to. Otherwise, it's not due until Tuesday next week. Don't worry about that. But, again, just be a little cautious. Now, one of the things that I would like to do before we move on past Chapter 3 is just a couple of quick review problems from Chapter 3 before we go on. Just things that make me a little bit nervous.
A nice review sheet for Chapter 3 with questions.
The review sheet that I have for Chapter 3 is sort of merged up into the test review, so I don't have a nice one this time. All right? Normally, I expect you guys to ask more questions on the homework, and so normally I don't need one. But anyways, all right, so I'm going to give you a variation on the theme this time. So let's suppose that for those of you who don't know, I live in Madison, and guess what happened to my basement? Yes, it flooded. It got a little on the damp side, and I used to have a carpeted basement. I now don't. I spent the weekend removing all of the carpet, and I was very happy that I did remove the carpet because, of course, what did I discover underneath the carpet? Yes. And so I spent a great deal of time trying to demold the floor in my basement because there was carpet on top of older carpet, and so the older carpet pad underneath wasn't mold resistant carpet pad. Yeah. So it was really bad. So anyways, I need to buy carpet for my basement. We were pricing out various different options for what to put in the basement, and the problem with it is that if you look to try and tile your basement, you're going to spend a minimum $6-7 per square foot. If you put carpet in your basement, you can get down near that $3 per square foot range. So in other words, cut the price in half. I don't have any kids. I don't need a finished basement, but it was finished. So now if you don't finish it, it looks really stupid. So
Carpet's better.
yeah, I mean it is. But tile is way the hell easier to clean.
But it's in the basement where it's already cold, so the tiles can be even colder.
Exactly,
That's
that's
why you
our.
put that stuff in the basement.
I know.
That's why you have a carpet.
I know. That's what we're debating. My wife and I are going back and
Well, what
forth.
happens when it rains again and you're flooding again?
Well, now you can figure flooding issue either way. If you put tiles or not tiles, maybe.
I know. Now you see the argument that my wife and I have been having for the past week and a half.
In retrospect, I would rather vacuum a carpet than sweep and mop.
Yeah,
At this stage, I don't
You
know.
have to clean a carpet, and then you have to go and get the special stuff to clean it.
All right. So okay. So we realize that it sucks, and we move on. But anyways. All right. So my basement has about 1,025 square feet. Yeah. It's got 750 square foot of a big, huge living room, and then another 275 square foot bedroom off to the side. It's not a real bedroom because it's in the basement and there's no closet, so I can't call it a bedroom, but
Just put a closet in there.
it's a bedroom, okay? Anyways, all right, so it's got 1,025 square feet. Carpet costs $265 per square foot. Padding runs 45 cents per square foot. We're putting in by far the cheapest padding possible. Basically, it's not padding, but it is, so that there's something there, and you're not stepping on basically concrete with carpet on top of it. And installation is 80 cents per square foot. And the only reason I found that out is because it turns out one of the handymen in my neighborhood, he actually runs a little mini contractor business, and he's a buddy, and so he's like, oh, you can do it, right? So I'm like, not bad. All right, so my question to you is, assuming no tax on any of this stuff, pre-tax, how much?
About $4,000.
So you have,
Shh, don't tell me that!
so you have to multiply each one of those by the square footage of your basement.
How much to carpet my basement?
Makes you feel better. It's not $4,000. Until you buy your handy guy's beer and a little over $3,000.
All right, so how would you calculate this, guys?
Do you have to,
0.65 times the 1,025 and just keep doing that down.
So one way to go about doing this is to say, hey, take the square footage and multiply it by each one of these particular numbers and add the numbers up, okay? Just be a little bit cautious with this, okay? So what is 1,025 times 2.65? Somebody punch that out for me.
27, 16, 25,
27, 16.25. 1,025 times 0.45. 461.25. And then last but not least, 1,025 times 0.80. 820. Oh, God.
you're gonna be broke.
It's just making me sick. Just looking at that. Like, so what does it add up to?
3,997.
3,997 even?
Man.
Oh, well, there goes my birthday party.
Yours and put it in yourself.
True. I can try that. But stretching carpet, that's a pain. Regardless, though, folks, there is a slightly easier way to go about doing this. Instead of multiplying all three of those numbers, yeah. Just add the prices and then multiply once. It saves you from potentially having to punch in multiple numbers on your calculator and finding a potential mistake along the way. Let's face it, folks, the more times you punch the calculator, the more times you are likely to screw the two numbers up. This, if you add these first, so if you add 265, 45, and 80, what does that run out to? 390? What's $1,025 times $3.90? $39.97.50 straight up. Okay? It just makes doing the calculation a little bit easier. The other thing that you have to watch out, and I don't know if you did this on the homework problem, is what happens if this measurement, 1,025, has a decimal in it. Yeah. What if I said it was 1,025 and a half square feet?
And then you count the decimal.
Yeah. When you multiply, are the numbers going to stop at the cents? No, they're going to go out to the next place past the cents. And technically, if you do the multiplication 3 times, you can't round until after you add. So on the homework problem, where these numbers had a half in them, when you multiply, you're going to get like 4,872.465. Do not round this to the nearest penny and then add them all up, because you will make a rounding error. Okay? So just be a little bit careful with that kind of stuff. If you just add up all of these numbers and add up all of these numbers and then multiply them once and round once, it will always work. You never have to worry about making rounding errors. But if you multiply multiple times, that's what can lead to rounding errors. Okay, folks? That's just me warning you a little bit about that, because I know there's that carpet problem on the homework. That don't make that mistake. Okay? All right. Let's see.
What Bless you.
All right, so it is 375 million miles to Mars. I have no idea if that's really correct or not. That's my guess. A trip to Mars by NASA will cost $48.5 million. It is cheap. What's the cost per mile? Cost per mile to get to Mars. And I will say here, because it's money, round to the nearest penny, just in case you are not sure where you should go with that. So, how do we do this one? What are you going to do? Divide the total cost by how many miles. So what should I do? Right? Tell me what to write down. $48.5 million divided by 375 million. Again, cost per mile. So put dollars per mile. Please make sure you divide the correct numbers. All right? This is a very classic thing for me to do on the test, is to give you a number first that really belongs in the denominator. Okay? That is just classic me. Okay? So please be ready for that test time. I love to do that kind of stuff. Because normally in most problems it goes the other direction. Now, how are you going to do that? How do you write out 48.5 million? 48, comma 5.
0, comma 0, 0.
That it? Okay. And now what are you going to do?
Zeros.
Yeah. Cancel out the zeros so that this isn't a pain in the ass to put in the calculator, right? I mean, that's exactly what you should be doing, right? Get rid of those last 3. Get rid of those last 2. What should you be pushing into your calculator? 485 over 3,750. Somebody punch that in really fast for me. 0.13.
I'm just assuming I did it the hard way. I punched it all.
So you're pretty sure you did it right, but it's one of those where you can't see it, right? And that's why it's a little bit nicer to potentially do it this way, right? And so technically, it's only going to cost NASA 13 cents per mile to get to Mars. Why is that? Because there's no gravity in space, folks, right? Once you get outside of the orbit of the of the Earth, what happens? You float, right? As long as you get out of orbit and are heading towards Mars, you don't got to do anything other than maybe correct so that you don't run into things, right? I mean, it's sort of important not to, like, run into the moon. You know, that would be bad. So if the moon gets in your way, you should E and then E to get back. But basically, once you the most of this money, most of this $48.5 million is in building the rocket and fueling the rocket and getting out of orbit. And once you're out of orbit, then it's like, who cares, right? Just drift. Probably takes a bit more than that. It's probably also more than 375 million miles.
You're going up there in a cheap ride.
But it's a Russian rocket. Come on, right now NASA doesn't build their own rockets. They buy them from foreign countries. And the only person building them right now is the Bezos. He's supposedly building them, but these are all tiny. And then that base out in Kyrgyzstan. Those are still making rockets. Of course, their rockets are built off of used parts. But whatever. I mean, that's what we take to get. That's what they take to get up to the space station.
We take cheap rides.
Yeah, it's a little nerve-wracking, but okay. So again, just realize, folks, that you know how to do these sorts of problems, and that you can round accordingly at the end. All right. Do I need to review basic division longhand? So if I asked you to do something like, let me just go to a new screen. If I asked you to do something like, what is 11.4 divided by 0.12. And I asked you to say, round to the tenths. How would you do this? Again, assuming you don't have a calculator, because again, remember, first half of the test is no calculator. You got to go in there basically cold and do math. No notes either. It is rude, but it's fun. So, how would you do this? Like so? So you're dividing 0.12 into 11.4, so 11.4 goes into the house. Now what do? Move the decimal. Okay, please don't forget to move the decimal, right? If you move the outside decimal too, what do you have to do with the inside decimal? Again, fill in zeros. And now it's good old-fashioned long division. How many times does 12 go into 114? Subtract. How many times does 12 go into 60? Now what do I do? Leave it. And how should I write 95 just to be safe? All right, good. So when you're asked to round a number to a specific place marker, please write the number to the place marker. If you just wrote 95, I'd probably give you all the credit for it, but I would probably, write a little sad face next to it. Because you should really write it to whatever place marker I told you to, even if it doesn't get there. All right? All right, so we're good? Okay. In that case, note, folks, that we are skipping Chapter 4. Chapter 4 is all about balancing your checkbook. And so it's basically adding and subtracting and then multiplying by taxes and multiplying by percentages. And it's a continuation of multiplying and adding and dividing decimals, and so I skip it. Okay? You will have to do similar stuff in a business class when you get there. They can do it. All right? So we are going to hop straight to Chapter 5. And Chapter 5, folks, is our algebra chapter. And we love algebra, right?
No,
All right, now, before we can jump into algebra, I just want to make sure that you are okay with some of the standard terminology that is sort of wrapped around algebra. And it's, hopefully most of it you understand or have heard it before, so. In math, folks, what is a constant? It is, the definition of constant is something that stays the same. So in math, what sort of thing stays the same? This is one of those really obvious questions that we're...
Numbers.
Yeah, numbers, exactly. Right? So if you say 3, 3 is a constant, because will 3 ever be anything other than 3? No, because then it wouldn't be 3. So, yeah, So, numbers. Now, please be a little bit careful. There are some numbers that we don't write down, and instead we use a symbol for them.
Letters.
Well, true, but those are variables usually. But what was that number? Pi. Why is pi not a letter, but really a number?
Because there's a lot of numbers.
Yeah, because it's an irrational number, which means that there's no repeating portion of it. You can't write it down without having to round it some way. So just realize that there are some letters out there that are really numbers and not variables, okay? There are more numbers than just pi. This is just the classic one, okay? We could talk about some of the other ones, but they're not something you need to worry about, so just don't sweat it. So, and numbers, 3 is a number. Please realize that any kind of number is a number, right? So if I said -4 2/7, that's still just a constant, okay? It's an annoying constant, but it's still just a constant. And of course, don't forget that 0 is a constant. It's just nothing. Yeah. So just, and again, you can have decimals, right? 4.5762, whatever. Those are all just constants. All right? Well, I shouldn't do this, right? Technically, if you've read the book in chapter 5 or gotten to chapter 5, technically, the book never actually uses the term variable. It instead uses the term unknowns. Apparently, the book and the authors seem to think that the word variable is intimidating because it's scary. It's not, folks. So the book will spend a great deal of time trying to talk about unknowns and how math is really an attempt to discover what the unknown is. And so it's a lot like space exploration, where we don't know what this section of space is like, so we have to go there to find out. And math is the same way. You're right. Unknowns are not as scary as variables, according to the book. Whatever. Anyways, a variable, folks, what is a variable? It's an unknown value, okay? So what sort of examples do we have for variables? What's our favorite variable? Okay, good, yeah.
Which phrasing, or I guess which term will we use like on the test? Are you going to say unknown or variable?
I will say variable. Yeah, I will say solve for the variable, because x is a variable, and you should just be able to handle that word, okay? All right. And again, it's perfectly okay to use y if you want to use y. If you want to use other letters in the alphabet, that's perfectly fine. If you want to use some German letters, and you want to use a Schloss, that's perfectly fine too. You know, what I tell people is that it's okay to use any kind of symbol, right? I actually had a student do this to me once. She used a heart as her X on every homework paper for chapter 5. It was hilarious, really. I mean, it was also really annoying, too. But the cool part about it is that what she did is, based on the problem, she colored the heart differently. person who had way too much time on their hands, I think. Right. So if she was happy about the problem, she'd color it red. If she was sad about the problem, she would color it blue.
She needs to get slapped.
Oh God. Okay. Anyways, and then last but not least, if she really loved a particular problem, she sent an arrow through the heart. That was really bad. I was like, whoa, what kind of drugs are you on? And where do I get some? But it was, again, if math for you is a little bit tedious, or maybe you find it boring.
Would be tedious.
Exactly. But now it's at least a little bit funny, right? Because every time you draw that heart, you have to giggle to yourself, because you know I'm going to be looking at it. And you can say, oh, Marshall. Right? And then you can, color it green because you barfed on it, or whatever. That's just, you can be as creative as you like with your variables. You don't just have to use X and Y. Just realize that I am going to use X and Y because I'm bored. So.
Can we switch your X and Y out?
Sure. I'm okay with that. All right. So again, variables, you can use whatever you want. Just be creative as you wish. All right. So. All right. This tends to be a term that most students don't remember that they know. An expression in mathematics. What an expression is a combination of constants and variables with math operators between them.
Yep.
So a combination of constants and variables that's with didn't really work very well. Math operators. What is a math operator?
Plus, minus.
Okay, good, yeah. Plus, minus, division, times, parentheses, square root symbols, exponents, etc. Okay, all the stuff that we can put in math expressions. Now, what's missing from these operators, though?
Equal sign? No, an equal sign. It changes what it is.
All right, very good. Note, no equal signs. Expressions do not have equal signs because when you put an equal sign up there, folks, it doesn't become an expression anymore. It becomes an equation. And that is where we are headed. When you are dealing with algebra, generally you are working with equations. And what an equation officially is, folks, is when you set two expressions equal to each other. So one side of an equal sign is an expression. The other side is a different one. And you're basically just saying that these two things are the same and that might mean something to you. All right? You can use that knowledge to potentially discover things and find out the unknown. Dun dun dun! Well, it's the start of algebra, folks. It can be a little dry, so I'll try and spice it up with opera. All right, so let's see. Okay, so note. Equations, folks, can be both true or false, right? Some equations are true, like 2 plus 3 equals 5. This is what's known as a true equation, right? You can also have false equations. This is an equation. There's nothing wrong with it. It's just false. Usually we don't like to write false equations. It doesn't make sense. But do note that technically equal signs are there to allow you to do things and to say things that should be equal to each other, but really what they are is just a Boolean operator that tells you things are either true or false. Okay? Again, don't worry too terribly much about it, but just remember that that's something going on. And now, our goal though is, and I should start a new page, hang on. So our goal, folks, is solving equations. That's our goal, right? So, in order to solve an equation, get the variable by itself by performing equal operations to both expressions of an equation. So this is sort of a classic algebraist's definition for how you go about solving an equation. Okay? It's basically the nerd way of saying, you know, get the variable alone. Okay? But this is sort of the idea behind it. Right? So, let's see, should I do some other stuff first? I don't know, we can just dive right in. I think you guys can handle it, alright? So, there are 4 standard steps that you will use to solve equations, to get variables by themselves, okay? First one. When you are adding a number to your variable, right now the variable is not alone, it's got a +1 with it. I don't want that +1 with the x. So what do I need to do to get rid of that +1? -1. And if you perform a -1, x + 1 -1, on one side of an equal sign, remember the definition? You must perform it on both sides. Do the same thing on the other side. 5 -1. And this is what keeps an equation balanced. So equal signs are like a teeter-totter. You don't want one side to flop down on the other side and have somebody hurt their gluteus maximus. So if you do something on one side of an equal sign, you must do the same thing on the other. Now, what is x + 1 -1? X. And what is 5 -1? Ta-da! Ooh, ah, right? Okay, anyways, that's the first step. If you are adding numbers to your variable, the way you get rid of those numbers in adding is to subtract them. Always perform the opposite operation, right? So, what am I going to do next? There you go. If I'm subtracting a number from my variable, how do I get rid of the subtraction of a number? Add it. Now, please note, folks, when I solve these equations, I don't write them left to right, I write them up and down. I'm going to write right below here that +2 equals +2, and I'm going to add going up and down instead of going left and right. Okay? Just because that's the standard technique that I've been using to solve equations forever. So, after I add the 2, what is -2 + 2? 0, and hence you're just left with x. And what's 7 + 2? No. Okay. Again, adding and subtracting, be able to undo them. If If you're multiplying by a variable, please note that when you have a number sitting in front of a variable, that is implied multiplication. Okay? This is 2 times x, not 2 plus x. Okay? How do we get rid of a 2 in front of a variable since it's multiplication? Divide. I write division using a fraction bar, folks, because I like fractions. If you want to write the little division symbol instead, that's perfectly fine. I'm okay with that. When you take 2x and divide it in half, you just have 1x, and what's half of 6? 3. And then last but not least, your 4th standard step. If you are dividing a variable by 3, how do we undo division? Multiplication. Again, don't use the little x for multiplication, folks, because then it looks like an x. That's bad. So that's why I tend to use the star. And if you have 1/3 of x and multiply by 3, that simplifies you down to x. And what is 4 times 3? 12. So these are the 4 standard building blocks that you will apply to solve any equation. Okay, any linear equation. All right, we are not going to do anything with exponents. You won't deal with any squares. You will not deal with any square roots in any of our algebra at all. And in fact, I am going to very diligently try not to have any equations that have more than one variable even. I'm going to keep this all to one variable algebra, and that's it. Okay? Takes a little work to get there, but hopefully you'll see it when it shows up. All right? So, now what we need to do is to start taking equations that have multiples of these steps built together and applying them. So, what happens if you have to solve 2x plus 1 equals 7? All right, now here's one of the questions or issues that we often have with solving in algebra. What do we deal with first here, folks? The 2 or the 1? Why? The weird thing is, folks, is that you actually, when you're solving, you work in reverse order of operations. You actually want to eliminate all addition and subtraction first, and then eliminate any multiplication and division. Okay? So, eliminate plus, minus first, then move to times and division. Okay? It's one of those things that you probably knew this anyways, but it's just one of those things that I want to formally write out just in case so that you can have it, all right? So in this case, since I have a plus sign, how do I get rid of that plus 1? I subtract 1. And since I'm subtracting 1 on one side, you got to be able to subtract 1 from the other. And note, whenever I'm performing operations, folks, I will try to use a separate color just so that you can see it. Subtract from both sides. Am I done? Not quite yet. I still have 2x equals 6. Divide both sides by 2. What is x here at the end? All right. Now, here's another step to dealing with equations. How do you check to make sure an answer is correct?
Of the 3 to x.
Yes, take your solution and substitute it back up into the beginning equation that you have and make sure that the equation is true. Okay? So one of the things that you should be able to do is plug your solution back into the equation and check. Check your answer by plugging, and that's not an official term. I should say substituting in your solution to the original equation. And prove it is true. Okay? So, what I tend to tell students is that you don't have to check your answers, and you also don't have to get an A in this class. So, totally your choice. If you don't choose to check answers, that's fine. But when you miss the problem because you didn't check, I'll just mark it wrong and not worry about it. Okay? I would like you guys to check your answers, but I'm not going to force you to. I'm not going to grade it necessarily, but it's just good for you. All right? So when you plug 3 back into this equation, right? You substitute it back in. Is that a true statement?
Yeah.
Why is it true? All right, so 7 equals 7, right? Because you do multiplication first. When you're checking, go back to using the order of operations the normal way. So you're going to do 2 times 3 first, and say that this is 6 plus 1 equals 7. And yes, 6 plus 1 is 7, and so 7 is equal to 7. All right? I know that example is a really easy example, and you probably didn't really need to check it. But the whole point is that when the equations start to get uglier, folks, it's less obvious that the answer is the correct answer. Okay? And doing this, prove to yourself that it is. Alright? Alright, so let's take it a step further. Let's see. I won't do another one with just 2 steps. Let's do one that's like this. Let's go with, let's say, 8 minus 2x equals 2. Okay, so what's slightly different about this, folks, is that this time I'm subtracting the variable. Okay? Now remember, you want to get rid of the pluses and the minuses first. So what do I do first to solve this equation? Subtract 8, right? Remember, we don't write it, but this is really a positive 8. So I need to subtract that 8 off, and I need to subtract the 8 off on the other side. And note where I wrote the minus 8, folks. Where did I write it? Right underneath the other 8, so that I was very careful to make sure I do 8 minus 8 instead of trying to do something like 2 minus 8 or something weird like that, right? Take advantage of stuff. And what is left over after you subtract this 8? Negative 2x equals negative 6. And this is where algebra starts to get annoying, when you have to deal with negative numbers. And this is why we spent a little bit of time back in chapter 1 talking about negative numbers, because in algebra, you're going to have to deal with them. You got to be careful, all right? So right now, I am multiplying my x by negative 2, divide by negative 2. Yes, it's no different than what we did just a second ago with the 2x plus 1. It's just that the coefficient, or the number in front of x, happens to be a negative number. That's okay. Your negative 2's cancel so that you're left with just x. And now here's where you got to be careful. What's negative 6 divided by negative 2? 3. A positive 3. And does that make sense, folks? Yeah. Because when you plug this number back in, what's 2 times 3? 6. What's 8 minus 6? 2. Okay, when the problem is this simple, you don't necessarily have to write out the check. That's a little overkill. But I would like you to at least put it back in with an arrow and say, hey, does it make sense? Do some quick arithmetic really fast and say, oh yeah, okay, it does. All right? All right, so again, just be careful with minus signs. Now, let's see. We're probably good with that. You will have to know how to use the distributive property, folks. You definitely have to apply it to some of the equations that we are going to generate in this class. How do I distribute that to? I had a student who liked to tell me that the distributive property didn't sound right to them. Whenever they heard the word distributor or distribute or distributive, they started thinking of car parts. And so what they said was, this isn't the distributive property, it's the rainbow property. And I was like, rainbow? Why is it the rainbow property? And the reason it's a rainbow property, folks, is that every time I used to teach this, I would always draw how to do the distributive property, right? What do you do with the 2? You distribute it to the x, and you distribute it to the 1. And what does it look like I have drawn? A little rainbow. And so my student told me that, well, you're really good at the rainbow property. Okay. Whatever, okay? Again, if it helps you remember what the distributive property is by calling it rainbowing, that's fine with me. Just realize that you are taking the 2 and multiplying by both the x and the 1. 2x plus 2. All right? So, you should be able to handle situations where I ask you to do 2 times 2x minus 3 plus 3 times whatever x minus 4 equals, well, let's make it at least sort of decent. So 10. I think that works. So, if you've got multiple parenthesis problems or multiple distributive properties to work with, you need to distribute them one at a time, okay? So, when I distribute this 2, what do I get, folks? 4x minus 6. I'm done with this piece. How about the next piece? 3x minus 12 equals 10. Now, one of the things that I would like for you to do is when you get this kind of a string of numbers or variables in an equation, simplify. Combine like terms. If you have 4 x's and you add 3 more x's, folks, how many x's do you have? 7 x's. And folks, if you ever have 7 x's, you really need to learn to make better life choices. Okay? That's a lot of alimony or child support. Alright? Now, please be careful with the next piece, right? This 6 is negative. This 12 is negative. If they're both negative, what are you going to do with them? Add them and keep the minus sign the same. Now it looks like one of our problems that we've already dealt with. Now we can sort of move forward the normal technique we did just a little bit ago. All right, so what am I going to do next? Right, get rid of the pluses and minuses. So add the 18. x equals 28. And then last but not least, divide by the 7. Final result. Now, how sure are you that x equals 4 is a solution to that equation? Can you just look at it and say, oh, I'm sure it's right. I didn't make any mistakes. This is one where you probably should take the number and plug it into the equation and make sure that the numbers work out. Okay? This is where checking an answer really can save you from making a silly mistake, right? If you accidentally did negative 6 minus 12 and looked at this as, say, oh, 6 minus 12, that's negative 6, because you didn't look at the minus sign there, when you go to check the answer, you'll be like, you plug it in and it won't work, right? So it's a really good idea to check, okay? Especially when the equation gets ugly, all right? So how does it work to plug it back in, okay? 2 times 4 minus 3. So note how I wrote the multiplication, folks. 2x, I wrote it in parentheses, okay? To keep track of it being multiplication. And then do the same thing with 3. Now, how do I prove that that's true? Do the math, right? Show that the numbers work out. So what do I do first up there?
The parentheses inside them.
Inside the parentheses. What do I do first here? 2 times 4. Good. And nicely enough, folks, what's 4 minus 4? What's 8 minus 3? What's 3 times 0? Okay, good. Please don't forget that when you multiply by 0, you always get 0. I like this problem because it sort of reminds you that 0 is a number you know how to work with. And last but not least, folks, what is 2 times 5? And there's where you get your check mark that these are the same values, and therefore you are fairly certain that the solution you came up with, x equals 4, actually works. Okay? So, please take advantage of that, all right, when you get the chance. All right, so, let's see. What did I do to you this time? X is on both sides of the equation. Crap, how do you deal with that? Okay, good. Note, when you have x's on both sides of the equation, you need to get the x's on just one side or the other. It doesn't matter which side, the left side or the right side is fine. Okay? My advice to you is do the operation that makes the problem easiest. Okay? So, you could, if you wanted to, subtract 3x from both sides of this equation. If I subtract 3x, folks, what happens over here? I get a negative x. Do you guys like negative x's? No, I don't either, really. So, I could also subtract 2x's. If I subtract 2x's, what happens? I have a nice positive x. Please work with positive x's. That's really nicer, okay? So my advice to you when you have x's on both sides of the equation, subtract the 2x from both sides and wind up with a positive x value. Okay? And again, note where I wrote those minus 2x's underneath the x's themselves. Last but not least, to solve for x, add 6. Does it matter that the x is on the right-hand side? No. Very good. Okay? Oops, I was going to do that in Final answer. 10 equals x. If you want to write it the opposite way, x equals 10, that's fine. Equal signs are reflexive, so it doesn't matter if you write it one way or the other. And again, just do it to make sure, right? What is 4 plus 2 times 10? 24, because you do the 2 times 10 first. What is 3 times 10 minus 6? 24. Okay? So, there's another quick way that you can do the check if the numbers aren't too painful, right? If there's not a whole bunch of equation material going on, it's perfectly okay to sort of do a quick little, hey, do these numbers work? Write it down and prove to yourself that yes, it does work, and give yourself a check. And when you do the checks, strongly encourage using multiple colors, right? I mean, very rare in a math problem that you get to use multiple colors, so feel free. Right? Pull out your red pens, your blue pens, your purple pens, your green pens, your polka dot colored pens, whatever you got, and use it, all right? All right, so this gets us basically to the point where we'll do maybe a couple more when we come back next week. But what we're going to start with next week is the fun stuff. All of this is really setting us up to doing word problems, okay? So on Thursday, we will just basically do word problems, or Tuesday of next week, word problems all day. Please note that our first test, not next week, but Tuesday of the following week. So next Tuesday, we will finish Chapter 5. On Thursday next week, we'll review for the test, and the Tuesday after that will be our first test over Chapters 2, 3, 4, 5. All righty?
Chapter 5 homework is due to the test day.
Yeah. You can turn it in that Thursday before, though. Official due date.
Let's see, yeah.
All right.